Welcome to the Python itertools module. In this video, we will explore how to achieve efficient looping using itertools, focusing on the chain, cycle, and combinations functions. Let's dive in. First, let's discuss the chain function. The chain function combines multiple iterables, such as lists or tuples, into a single sequential iterable. The key benefits include memory efficiency, as it processes one item at a time. It can combine any number of iterables and preserves the original order of elements. Here's an example. We begin by importing chain from the itertools library. Next, we have two lists, numbers and letters. The chain function combines these two lists into a single iterable named combined. Finally, we iterate through the combined chain and print each item. The output will be 1, 2, 3, A, B, C. Now let's explore the cycle function. The cycle function creates an infinite iterator that repeats elements from an iterable. Key features include creating endless loops from finite data. It is memory efficient, as it only stores the original iterable. It is perfect for round-robin processing. It must be limited with a counter or break condition to avoid an infinite loop. Here's an example. We import cycle from itertools. We have a list of colors red, green, and blue. The cycle function creates an infinite cycle of these colors. To avoid an infinite loop, we use a counter to get only the first 7 elements from the cycle. The output will be red, green, blue, red. Now let's dive into the combinations function. The combinations function generates all possible R-length combinations from an iterable. Key characteristics include that the order doesn't matter, unlike permutations. There are no repeated elements in each combination. It returns tuples containing the combinations, and it offers a memory-efficient implementation. Let's look at the example. We import combinations from itertools. We have a list of fruits: apple, banana, cherry, and date. The combinations function generates all 2-element combinations from the fruits list. Finally, we print all the combinations. The output consists of tuples: apple and banana, apple and cherry, apple and date, banana and cherry, banana and date, and cherry and date. Let's explore some practical examples using itertools. First, we'll look at a data processing pipeline. Here, the itertools.chain function is used to process data from multiple sources as a single stream, improving efficiency. Second, we will examine a team assignment rotation. The itertools.cycle function is used to assign tasks to teams in a repeating round-robin fashion. In summary, the itertools module provides memory-efficient, high-performance tools for creating iterators for efficient looping. These functions help write cleaner, faster, and more Pythonic code for data manipulation tasks. Let's recap the Python itertools module. Here are some resources for further learning, including the Python documentation, real Python tutorials, itertools recipes, and the Python cookbook. Here are some additional itertools functions to explore, including permutations, product, islice, and group by. The key takeaways from this module are memory efficiency, cleaner code, faster execution, and a more Pythonic approach. Thank you. Let's compare code with and without itertools to see the transformation. Without itertools, combining multiple lists requires nested loops and manual appending. Creating combinations also involves nested loops and manual pair creation. With itertools, the chain function simplifies combining multiple lists into a single line of code. The combinations function generates combinations with a single function call. In conclusion, using itertools leads to more concise, readable, and efficient code. It eliminates nested loops and complex logic while improving performance. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.